In our next lecture, we will discuss complex data types, and essentially these are mappings and structs. Let's see a very simple example. You can find the code on the CBC simple mapping.sol code file, along with a couple of more that have a little bit more of a much more difficult setup in terms of mappings and structs. And mapping essentially is what the word says. So you map a key to a value, and here, for example, I start with the word mapping. I declare an integer and then a bool, and then I call this my mapping. Or I can map an address to a bool variable, which is also public, and essentially sets the name as my address mapping. And the key can be any variable other than another mapping or another smart contract. Essentially, it is certain that you can use mappings inside structs, which we will see there later as complex data types. So what we have here is an initialization of 4 variables, which are called myvar1, myvar2, myvar3, myvar4, all false, and these can correspond to specific addresses through the mapping that we have here. And the following function allows you to set the index of a uint to map as true in the mapping instead of mapping as false, which is set globally at the beginning here. So this set value actually changes the my mapping, and the set my address to true essentially changes the second one by using the code of the global object of the method center. I've compiled and essentially called for that address. And you see now the first address is the 835 CB2, which is the one I use to actually call the contract. Sorry, let me change addresses. So I will set my address to this one. And I get an invalid address because I did not use it. And let's say how I can set the value to 2. Apologies, this only would read from the blockchain, and it tells me here that it has essentially mapped the new address to the next boolean. Let's take a look at a couple of more pieces of code in terms of mapping. So you'll see here that I have a very simple one called mapping struct example C. Let's try this one. The warning has to do with not having a license identifier. I'm going to deploy the mapping, and let's take a look at what happens here. Essentially, what I have is a map of addresses to specific integers, right? And this is called the balance received. And essentially, I can use this mapping as a very easy way to create a credit account for specific accounts. So every time one of the addresses will send money to this specific contract, I will be able to credit. So I will say 1 Ether from the first address. And let me change now the address, and you'll see if I go to balance received for this one, it will say 0. But if I go with the first one, it will tell me I do actually have credit for the first address. And this gives me the credit for all of the contracts. So with the second address, I will go 10, send money, balance received. I need to also input that address, and you'll see that it's 10, and the full balance is 11 Ether. And now if I try to withdraw 2 Ether for this address, you see that I haven't set specific conditions so that I'm able to withdraw amounts which are less than the one I've received. So we need to change the contract essentially so that it takes into account events and certain conditions on these transactions. Let's take a look at the idea of mappings, right? So essentially we have a key value which is assigned to a value type, and this is named. A key type can be any elementary type, any of the built-in value types plus bytes and strings, and the value type can be any type including other mappings. All mappings are initialized by default. They do not have to have a length, and public state variables of mappings become a getter function. So you can then call the mapping from the contract. Structs are a little bit more complicated data types. They are essentially composite. So within a struct, you can include any kind of other variables that you want to combine. For example, here I declare an address and a uint as a serial number. And then you can access structs as the name, so it's underscore name dot address for the address and underscore name dot serial number for the serial number. Be careful that structs cost less gas than classes. So try not to declare classes within contracts themselves, but declare the structs and the functions separately. We can, of course, have declarations of structs within mappings, and that makes it easy to create complex conditions and complex behaviors for the blockchain. And we won't take a look at arrays, but I wanted to actually discussed that they are possible, but because of gas cost, it is always better to use mappings. So if you're familiar with arrays from other languages, be ultra careful of how you use them, more so if you try to use a dynamic size array, because it might wreak havoc with the complexity of the computation. And dynamic size arrays would make it very difficult for you to calculate how much gas a computation will take. And then you also have enums as complex types. Internally, they're integers running from uint8. When they are uint8, they run from 0 to 255 in the ABI. And more than 256, you go above with uint16. And here's an example. You can declare direction choices enum, where I will give already the options of go left, go right, go straight, and sit still. And those 4 options will already be assigned to an integer. And then I can essentially very simply declare which option I want with the final phrase you see at the bottom. I think that probably was a lot for people to take in. Does anybody have any questions so far? Would you like some time to try some of the things on the variables videos? How expensive is it to store strings instead of numbers? It depends on whether you, so there are essentially 2 places you can store things. If you want to permanently record it on the blockchain, if that's what you mean with this, it will cost more gas, essentially. There is also the working memory of the Ethereum virtual machine. So essentially, like any other computer, you can hold things in memory until you need them to be recalled. So always try to be very careful about what you will need to write, as essentially more bytes and more bits essentially will be more expensive. You can try a gas calculator. I'm going to try and paste one here later on, because essentially every transaction would can be costed, and you can calculate essentially how expensive a smart contract is before you have to deploy it. Yes, you can keep it in memory. So when you declare a variable and then the function that uses it, you can declare to keep it in memory rather than using it using the permanent storage.
Just for the purposes of the recording, that question was, is there a way to store a string or a hash in the contract without using the permanent memory in the blockchain? Great.
Yes, so you use essentially the working memory of the EVM, and as long as you don't change that string or hash, it will keep it in memory.